first thing that you guys are going to be doing is you're going to find your favorite partner, and then you're going to go back there. That's where all the hardwares are found, and you're going to weigh the nut, the hexa nut. Okay? The best way to determine the mass of a hexa nut is not to measure each one individually, because each one of these hexa nuts, they're not all perfect, are going to weigh differently. So what you want to do is probably take about 10 of these, put it on the scale, tear the scale. When you tear the scale, it basically zeroes it. Put 10 of these on the scale, record that mass on the lab notebook, and then divide that number by 10. Okay, that way you get an average. You want to get an average. So, we need to measure the mass of one hexanut. That's important. It's like determining the mass of one nitrogen molecule. Okay, and then that one nitrogen atom will combine and form other molecules. And so, what you want to do next is determine the mass of one bolt. The best way to do this, again, is to take 10 of these bolts, put it on the scale, and then divide by 10. Make sure you show your calculation in your lab notebook when you do that. Then when you're done with that, there's a container that looks like this in one of the containers back there. This is called a BN chemical. Okay? It's called a BN because there's one bolt and one nut. So that's why we call this a BN chemical. But you notice that this thing is enclosed in a plastic container, and I don't want you to open this. It actually gives you the mass of the container right in the front on the label. Okay? And then there's two of these. So what you guys want to do is you want to first weigh this, write the gross mass on your lab book, and then subtract the mass of the container, and that will tell you the mass of the two bolts in here, the BN. And then you need to divide it by 2. Okay? So don't forget to do that, because in previous semester, students were really off on the mark because they forgot to divide by 2. There's 2 of these in each one of these. So that's why you need to divide by 2. You do the same thing to the BN2 chemical. There's another container back there that is labeled BN2. You do the same thing. You want the weight of each one of these. It's like determining the mass of each molecule. Okay? Then you do the same thing for a BN3. You weigh it, you subtract the mass of the container, you divide by 2. And then lastly, you weigh BN4. Okay? So that will get you to the bottom of page 159. Pretty straightforward so far. You're just weighing things and trying to get the mass of each one of these items. And then on page 160, you're going to determine the mass of 20 grams and 20 grains and beans. That's what this is. Okay? 20 beans and rice is in here. So what you want to do is you want to weigh this again. You want to subtract off the mass of the container. And if you divide by 20, you've got the mass of each bean-rice combo. Okay? Since there's 20 in here, you want to divide by 20. So that's the mass of each bean-rice combo. And that's the second line on page 160. Okay? The last thing is to weigh these items. This is an iron cube. Just put it on the scale, make sure the scale reads 0, and then weigh it. If you know the mass of the iron and you know the molar mass of the iron, then you can figure out how many moles of iron is in here. And if you know how many moles of iron is in here, you can tell me how many atoms of iron is in this cube. And that's one of the calculations that you guys are going to do. Is tell me how many atoms of iron is in this cube based on the mass. Again, we're counting by weighing. That's the first item on page 160 on weighing objects. The next is 50 milliliters of water. What you need to do is take your graduated cylinder, make sure that the scale is tiered, put the graduated cylinder on, weigh it, okay? And then fill it to about the 15 milliliter mark, and then weigh it again. The difference is the mass of 50 grams or 50 milliliters of water. And the 50 milliliters of water, you can determine the mass of that if you subtract the difference. Okay? And that's because based on that mass of water, you're going to calculate the number of molecules of water in a later calculation. You're going to use, of course, the molecular weight of water to do that. So far it's not too difficult. You're just doing a bunch of weighing. Okay? The last item here is a bag of sugar, right here. This is sucrose C12H22O11. Okay? Because I gave you the formula, you can determine the molar mass. Okay? You're going to weigh this on the scale, and then you're going to subtract the mass of the container. That'll give you the mass of the sugar. Based on the molar mass of the sugar, you can tell me how many molecules of sugar are in here. Okay? Again, counting by weight. Then you're done. You're pretty much done with the lab as far as getting information that you need. Now to determine how many chemicals are in these unknowns. Okay, these are unknown. Unknown number 5, unknown number 13, beans and rice unknown, unknown bag E, and unknown bag D. So all of these are unknowns that you guys are going to analyze starting on page 161. Starting on the top of page 161, you're going to take a bag of unknown A. I believe that's what this is. This is unknown A. It's going to be labeled in the back. Okay? What you guys are going to be doing with this unknown bag A is first identify this unknown as unknown number 3. It's going to be here. If you do not identify it, you don't get any credit for this part. Okay? Because I'm just going to assume you got it wrong. You need to identify your unknown. Okay? Once you identify it, then you put it on the scale. It'll tell you right here that that the container, the total mass of the bag plus hexanut, the container plus the hexanut is the total mass. So you tear the scale, you put it on, and you read the mass. And the mass is going to be the nuts in here and the container. And then the mass of the bag is what's written on here. And so you subtract the two, you have now the mass of the hexanuts in this particular container. Okay? You're not allowed to open it and count. Okay? Then, based on the fact that you know the mass of one of these, and you know the mass of these, you can tell me how many nuts are in here. If, for example, one of these weigh 1 gram, and you've got 26 grams in here, then 26 divided by 1 tells you there's 26 nuts. Okay, it's that easy. You're done with that part. That's your first unknown. The second unknown is unknown bag B. Record your mass again. That's what this is. And in this particular case, it's a BN. You do the same thing. You zero your scale, you put this bag in, you weigh that out, you write your number, you subtract the mass of the container, and now you have the mass of the BN chemical. You know the mass of each BN chemical from a previous calculation. Okay, so you have the mass of a BN chemical, and you know the mass of this particular BN chemical. Those two information should allow you to calculate how many BN chemicals is in this container. Okay, so that's the second step. The third step is to take bean rice. Okay, the same thing. You zero your scale, you put this item into, and there's a lot of bean rice as you can see from down here. There's too many to count, so don't bother counting it. You want to count it by weighing. That's the name of this lab. So you want to weigh it, you want to subtract the mass of the container, okay? And when you do that, you have the mass of the bean rice combination, and then you know from a previous data how much each bean rice weigh. So you use those two information, you can tell me how many bean rice combination are in here.
And that's still a 1-to-1 ratio, right?
It's still a 1-to-1 ratio, exactly. Okay? So that's page 161. You're just counting by weighing. Okay, you're doing that analysis. Page 162, you've got bags D, bags D and bags F. In this particular exercise, you are going to determine the chemical formula of the items in here. Is it Bn? Is it Bn2? Is it Bn3? Is it Bn4? How do you do that? Well, first of all, you need to weigh it. You weigh it on the scale, you subtract the mass of the container. Okay? Then I tell you that in this particular bag, there are 6 unknown. I tell you how many. So you take that mass and divide it by 6, it'll tell you the mass of each individual chemical. All you've got to do now is compare it to these items that you previously weighed. Is it closer to Bn? Is it closer to Bn2? Is it closer to Bn3? Is it closer to Bn4? Okay? If you compare it that way, you should be able to identify the chemical that are in these bags. Okay? So a lot of it is just like scavenger hunt, except you got to use a little bit of math. And then finally, the last part is to do the calculations part 4. But that's your lab. Okay? You just have to weigh a bunch of things and then calculate the net mass, and through math manipulation, count how many items are in these things, or determine the formula. Okay? It should go fairly fast. The calculations are the most difficult part because you've got a bunch of calculations at the end, but otherwise the lab should go pretty straightforward.